Hi, Emma and Chris. I think Catherine is going to join us in a moment, and Harsha. Hello, Harsha. Hi, Harsha. How are you?
Sorry, I'm just, yeah, just a moment. Hi, Laria.
How are you?
Good, not too bad. Much better.
Oh, good. I'm glad to hear that. I think Emma and Chris, they are online as well.
Yeah, okay. So hi, Emma
And
and Chris. Have we
and
met before? I'm not sure. For physics, I don't think so.
I don't think so. We haven't. We've just met via email. I think Ken ran the original physics
Okay. Oh,
webinar
yes.
at
Oh,
the end
yes,
of
yes,
March.
correct. Okay, so they are not, yeah, so they're unable to turn on their camera as well as their mic as well.
Oh, I can see that now. Okay.
Okay, there's a question there.
Can you change my permissions? We can't turn on our own mic and video, Emma says.
Sure, I'm just gonna be, okay, people. So
And I
Emma,
will,
I'm just gonna make them, I'm just gonna make them a presenter, so then they will be able to turn on their camera as well as the mic. Yeah, they should be able to now. Hello,
hello.
hi Emma, and hi Chris.
Hi. Hi, Emma and Chris. How are you? So
Great.
this is, I don't know, I don't think we ever met like face to face, not even virtually before. So my name is Ilaria, and this is Harsha that I don't think you met either. So Harsha is going to pull the strings in the background. She'll make sure that if people want to pose their questions, vocally, they can be unmuted, etc. So that Harsha will make sure that the webinar runs smoothly. And that's Catherine.
My best.
Yeah.
Catherine! Oh my gosh, the dream.
Hi, Catherine.
That was a nice reaction to my arrival.
Oh, that's great.
Oh yeah, perfect. I was just I was about to ask if Emma or Chris could just share their screen, and yeah, it looks great.
We can't see anything when we do this, just so you know.
Can you not?
Oh.
No.
See the screen.
Have you got another screen maybe so you can split the two screens?
We could use that one, but it's not really worth it.
Doesn't really.
I think as long as you're aware that we won't be able to see any gestures that you give us. Like if something's going wrong, we won't see a panicked face. I think it's okay. Yeah.
I'm sure it will all go okay. Just one thing from me. There are a couple of slides. So Emma, thank you very much for including them in the deck. One is obviously the housekeeping slide, where I need to tell people how to use the chat box if they need to communicate with us, etc. And then the other one is the slide with the two of you, the presenters. So if you could display the slide with, the first one with the housekeeping rules and the second one with the two of you, so that I can read your biographies and people don't see me reading, which is not an interesting sight. And but I think other than that, we're ready to go. I shared some of the questions that have come in. So they're not specifically about physics, but I thought that, it was useful to share them in case, so you can see the kind of questions that are going probably to come in towards the end of the webinar. And I think, Catherine, you're going to keep an eye on the chat in case there are questions coming in.
Yeah.
Okay.
Yeah. Just to kind of look ahead, I think we're unlikely to know the intricacies of the chemistry or biology syllabuses.
No.
We
Yeah.
don't.
No, that was not what I meant. You don't need to obviously answer questions related to chemistry or biology, but just in case there were similar questions coming in for your subject.
Yeah.
That's
yeah. Perfect.
Okay.
We'll try.
And how are things where you are? What's the weather like in Norway at the moment?
Great. I think it's, well, it was great.
It's overcast today. It's great. It's not great.
Overcast is quite great compared to what it can be like.
We've
It must
also
be beautiful when
got our
it's sunny.
pots.
Oh,
Nice.
beautiful.
I gave mine. I went on a school visit a couple of weeks ago and gave mine all away, so I had to reorder mine.
We thought we might try and sell them online now. You'll have an auction.
We'll open the eBay link at the end of the call.
No, eBay.
Touched
They
by
look great.
Let's sign copies.
Yeah, signed copies. Yeah.
Oh. No, weather is not so good. But I've been for a swim.
Oh, in the
Oh,
field.
nice.
Oh, wow.
It wasn't
Oh,
a
wow.
comfortable swim.
Was it not?
No. But nonetheless, got in.
Very
That's
good.
really lovely. Yeah. It's nice to be living close to the sea, I think. That's something that I'm missing. But yeah, in Oxford we have the river, which is water, so that's okay. But yeah. And also the weather here has been, the weekend was amazing. It was really
Yeah.
beautiful and really beautiful sunny weather, really warm. But we've gone back to grey.
I think it's the
Right.
sun is coming back for next weekend. I think so.
I
It
hope
should be good.
so.
Yeah.
Yeah.
Just gonna try something clever. No, I don't think I can. Ignore me.
What was it you were going to try?
Oh, I was gonna try and do the thing where you like minimize a slideshow once it's already open and kind of try to be able to see some aspects of the call while that's happening. But I think that's maybe a Zoom function that I'm more familiar with. So
Okay.
Teams we will keep it as simple can be.
Yeah.
Just, so
We used to use Zoom, but then we had to change to Teams for various reasons. So that I think it's only a matter of getting used to it. But for my personal calls, I still use Zoom because I don't know, I find it easier.
yeah.
But yeah.
Yeah. I'm going more old-fashioned, trying to just use the actual phone more often. Nice not to have to look at someone's face. Or I go to Chris's house.
Actually go to the person, yeah.
Exactly. So I think Harsha is typing something. I can see that she's maybe not. Can you share your
Yes, Ellery, I
screen?
just want, yeah, I mean, would it be okay
Yes.
for you to just share your screen? I mean, like, just in case there's an
Yeah.
issue.
Let me
So,
just yeah, I'll do that.
yeah, because did you share a link with me with the PPT? I mean, I'll also just save it in case.
I will.
So-
I think I did, but I'll send it again.
I just want to get rid of this.
And while you share your screen, then we need to just check with Emma and Chris whether are they able to access or see your screen.
Okay.
Thanks.
Just 1 second, because everything is going really slowly at the moment.
Sure, sure.
I don't know why.
Started cutting my own hair.
Yeah. So expensive here.
It's very expensive here, like 90 quid.
Oh wow.
Yes, I've heard that Norway is very expensive. I have a friend who's Norwegian, and she's always finding London not that expensive.
Yeah,
So I
although
think
there's never been a cheaper time to visit. The kroner is cheaper than ever. So now is, even though it's still going to be the most expensive place you visit in a year, but now's the time if you're ever planning to come.
Let me just find the webinar.
Looks good. Roughly.
Yeah.
No, the deck.
Can't tell you cut it yourself.
Get students to cut my hair sometimes, and then I have to go and have it cut properly afterwards.
Yeah, yeah.
Oh,
Uh,
Harsha, for some reason, I don't seem to be able to find it.
Okay, so let me check. It was on in one of the emails yesterday.
It was
There
in
was a
one of the
link.
emails.
Yeah, there was a link that was shared.
Yes.
yeah, it's a massive file, so I wasn't able to share it as an attachment.
No, it's fine, absolutely fine.
Even for me, it's not
I don't know why I can't
responding.
find it. It's very strange.
And for me, I don't know why it's just appearing as not responding.
Oh.
Okay.
And guys, can I just check, is this an hour call in total? Or I think with the last one we finished after around 45 minutes, I think.
Yeah,
Or is it half an hour? Sorry, can you remind me?
I think I
have an
said
hour, but it
we
can
have
be
an
shorter.
hour. Yeah, but it doesn't matter if it's shorter.
Because I noticed it was kind of billed on the website as a sort of ask us anything. So we'll not be shy of maybe giving a bit of a whistle stop tour on the
Yeah,
with the idea that
definitely.
and I've got my watch by my side. I mean, it will be what it will be, but we'll not be shy
Absolutely.
of coming to the end of the formal presentation quite early.
No, that's absolutely fine. Oh, sorry, Emma. I don't know if I've just seen your email from this morning. I don't know if there's some reason emails are coming in really slowly.
Yeah, I've got email problems this morning as well.
So it's trying to connect to the server. Harsha, have you been able to find the link to the deck?
Oh, yes, I have, and I'm just downloading it now.
Thank
So
you.
I wanted to, yeah, you're most welcome. I just wanted to quickly share my screen to just make sure that in case if we need a backup. So Emma and
Yeah.
Chris should be able to, yeah, so just, it's just downloading. But it's a huge file, so it's taking a while. Okay, just a
Do we
moment.
know how people are waiting in the lobby?
Yeah, but yeah,
6:37.
but then we still have like around 5 more minutes,
Yeah.
or maybe like another 4
Mostly.
4 minutes, yeah.
Okay,
additional
so,
top up.
okay, I see, yeah.
I'm sorry, I'm just going to check one message because my daughter, who's in school, has been texting me. Okay.
Did you want to say a bit about this time?
No,
Okay.
All done.
that is what it is. I think I made this bit, but I think.
You did.
Sometimes I read stuff I've written, think like, what? How did I like that? What am I on about?
So when is the summer holiday going to start in Norway?
Thursday afternoon.
Oh,
Okay.
nice.
Oh, you very close.
Yeah, it's going to be good.
Yeah.
Although it's my first international school, so I wasn't quite prepared for the absence of midterm breaks.
And how long is that going to be, the summer break?
Well, I'm an unusual person in that I'll be running our IB results process. So
Okay.
I'll have about 3 weeks, and then I'll sort of hopefully get a decent week after that as well. But I think it'll be a bit more interrupted after that.
My daughter, she goes to an international schools and they do the IB. So she's doing that, but she's MYP at the moment because she's only 14. So yeah.
So I'll mostly just say things and then just notice whenever you want to say something.
Yeah, I'll just jump in whenever.
Go ahead.
Yeah.
Okay, so do I just quickly share my screen?
Yes, please, Harsha. Thank
Yeah.
you.
Oh, you are most welcome. Just a moment. Share screen. Okay, so are you able to see my screen, Emma and
Yes.
Chris? Perfect.
Yes.
Yes.
Great. So I'm just going to stop sharing now. Yeah, so I can see that we have a few, well, around 5 people in waiting in the lobby, and we still have another. So maybe in the next minute, shall we just start inviting? I mean, like I'll just start admitting all of them. So at least we have 2 minutes before we start.
Yes.
Yeah?
Okay.
Perfect. So all the best, Emma and Chris. And would you just mind sharing your screen so we have, like the first screen open with where it says like IBD physics.
One sec.
Yeah, sure. Great. Yes.
Into the computer.
Perfect.
We can't even see each other's faces.
Oh, hello, everyone, and welcome. We're just going to wait for another couple of minutes for more people to join, and then we'll start with the webinar.
Can we talk?
I think we can talk.
If we talk, can people hear us?
Yes.
Oh, welcome everybody.
I think so. We do have some people in.
We can't see anybody.
We can't see you. You can hopefully see and hear us.
We can see you and we can hear you. Okay.
That's nice for you. We could see something.
Next time, 2 screens. You could construct this model plane if you wanted.
Yeah. Could be doing that as a meeting.
So I think we just waited for another minute and then we start.
Maybe sing a song. You can sing a song.
I could sing a song, but this is already being recorded.
Oh.
And yes, if it's
Your chance.
if you could start introducing yourself on the chat, that would be lovely. Thank you.
We'll see all of those chat messages after we've just
Yes.
stopped sharing.
Yes, you will see them afterwards. So I think it's 10 o'clock. So I think we're ready to go. Hello, everyone, and welcome. My name is Ilaria Parodi of the International Schools team at Pearson, and we're delighted to have you here today and that you are joining us for today's webinar for where we will talk about physics for the IB diploma program. Before I introduce our speakers, I would like to draw your attention to a couple of housekeeping matters. If you need to communicate with us, if you're experiencing any issues as we go along with the webinar, please put them in the chat box and we will aim to resolve them for you. Also, if you would like to pose questions on today's webinar, please use the chat box. There'll be time for questions at the end of the webinar, and I know that some of you have submitted their questions already, so thank you very much for doing that. But there will obviously be time at the end of our event to pose your questions, and we'll aim to go through as many of your questions as we can then. The webinar today is going to last for about 50 minutes to an hour. It's being recorded, and you'll be able to access the recording after the webinar. The recording will be available from our website. And now, without further ado, I am delighted to introduce our speakers, Emma Mitchell and Chris Hamper. Emma is the academic program leader at United World College, UWC, Red Cross Nordic, Norway, where she teaches physics. Emma is an advocate of the IB's approaches to teaching and learning, as is also an IB physics consultant for InThinking. Emma recently completed her doctoral research in curriculum, pedagogy, and assessment. She enjoys hill walking and playing guitar. Chris Hamper has been teaching physics since 1995, climbing rocks and casting flies at the United World College, UWC, Red Cross Nordic, situated on the west coast of Norway. Before that, he was the head of physics at UWC Atlantic College, where he studied the motion of waves while sitting on his surfboard. And now over to you, Emma and Chris.
Thank you so much, Ilaria, and thank you so much, everyone, for joining us on the call. It's kind of appropriate, I think, that we've got here our little prop textbook, which shows a surfer on the front cover.
Not me.
Not Chris. And we're also very, very excited to have our higher level edition in print as well, which has this fantastic wheelchair race in action. To show you a little bit more about where we are, 1 month ago, at the beginning of May, we had snow here at our beautiful fjord. And a month later, now we have most days with blue sky, and it's almost warm enough to have a comfortable swim.
No, it's not.
So in this session, we're going to walk you through what we think the main highlights are of the new diploma program physics guide. We will then explain how our textbook, we feel, aligns with this guide in a particularly helpful way. We'll talk about some of the resources we've made for teachers.
She's saying we here. I think she's going to do it, not me.
Chris will chip in. And then finally, as I think this event was billed as a sort of ask us anything linking to physics or maybe bouldering, not so much guitar. So I'm sure everybody on the call has had a chance to get to know the new guide. I haven't had as much time for this as I would have liked because I'm the exams coordinator at my school, but at least I've had the privilege of being able to write this book along with Chris. So the big themes are space, time, and motion, the particulate nature of matter, wave behavior, fields, nuclear and quantum physics. The IB has taken the measurements and uncertainties topic out of the main learning points, instead listing what they consider the tools of a physicist to be. And there are 3 categories of tools: experimental techniques, technology, and mathematics. I think the intention with these is that teachers will include these throughout the course and have a bit of an idea about where each of the tools will come in most useful. My fear is that perhaps without thinking this through, that students might be without a particular tool when they approach a particular topic and might feel a little bit lost. So that's something really worth planning for, perhaps in a way that we used to not have to with the measurements and uncertainties topic. And then finally, the other big headline in the guide that you'll notice is the inquiry process. That's exploring and designing, collecting and processing data, and concluding and evaluating, which of course we all know and love in the IA, but as you'll see in the guide, many, many more pages devoted to these things. The themes themselves are then broken up into the topics. I won't read out all of these for you now. Again, I'm sure you've had a chance to see them through. But I think what's quite interesting is the way that these asterisks are used. So many of the topics are for all IB physicists, standard and higher level. Those with 2 asterisks indicate the topics where most of the content is at standard level, but there is additional higher level material within them too. And then some topics are exclusively for higher level students. And I think this already gives us a little bit of a clue about how one might go about planning a program of study. particularly in schools where classes are mixed or those in which standard and higher level classes are taught by the same teachers, it might be a wise idea to leave the exclusively higher level content until the end. What makes this an IB diploma programme physics course, rather than merely a generic physics course, as you'll find in many national curricula and universities and schools around the world? Well, there's attention to detail in terms of nature of science and nature of physics. Of course, there's the IB learner profile, the idea of conceptual learning. The IB has its approaches to teaching and learning. There's a collaborative sciences project, formerly known as the Group 4 project, that all students will do over a 10-hour period. For me, that's probably the highlight of the whole IB diploma programme, something that's mandatory but ungraded. We've got assessment objectives, which involve knowledge, understanding and application of that knowledge, and the ability of students to analyse, evaluate, and synthesise. And then finally, can they take all of those skills and plan an insightful and ethical investigation? The IB course, of course, has internal as well as externally examined assessment. And then many of our students will incorporate what they've learned in physics in their theory of knowledge, exhibition and essay. And of course, they might take physics as their extended essay. How does our book tackle all of this? I think the easiest way to see the evidence is in our contents page. Our introduction includes the aims, the nature of physics, the nature of science, learning physics, inquiry, and the learner profile. And we don't just list those from the guide. We talk in our textbook about how teachers can plan for these. And I think they speak directly to students about what it is to be a student of physics. What is it they'll learn from the course, and what is it they'll take to the next stage of their education? We, of course, have a section on how to use the book. Sometimes I think it's really tempting to open a book at the chapter of the topic that you're studying and simply dive straight in. But in the book, we've got a really interesting types of boxes that we'll talk about later. And also, Chris has written, I think, a pretty impressive sort of discussion around how it is we observe things, then seek to explain what we've observed, maybe come up with a law or draw upon laws that already exist, and then use those laws to solve problems and maybe to explain future observations. And we've got a chapter all about the skills. Although we don't address the experimental techniques, technology and mathematics in full at the beginning of the book, we've provided a checklist of those that we do address in that chapter and the locations of where you can find the rest of them. So, for example, we don't take all students through exponential relationships in the introduction, but we do tell you in which chapters that comes up. And then, of course, as you'd expect to see, the chapters. And unlike the previous edition of this book written by Chris on his own, in this one, with me coming on board, we have written the chapters as they are in the guide. So there are 24 topics. We have 24 chapters in the higher level book, and the correct number, of course, for standard level.
Yeah, the reason I didn't do it that way before was that I refused to do it in a silly order, because the previous syllabus, to do it in the order of the syllabus didn't make sense. So I sort of persuaded the publisher to do it in my order, but that then confused a lot of people and students because the numbers of the chapters weren't the same as the number of in the syllabus. So maybe this is a bit easier to use now.
We also are really pleased to say that both Pearson and also the IB, with whom I'm very pleased to say we have written this book in partnership this year, they have kept us really to account in terms of not assuming that the previous knowledge that happens to be presented in the book is known for the later chapters. So I think it's quite reasonable that a student could open up the book in E1 Structure of the Atom and understand almost all of what's going on in and of itself without having to draw upon too much from what's come before as it is in the book. So I think this does a really good job of supporting you in whatever order you choose to teach. We also have this physics flowchart. I mentioned that the guide has this inquiry process, and the diagram of on the right is from the IB's own guide. So we've got the approaches to learning around the outside. They surround the tools of a physicist, and they in turn link to how it is that students embark on inquiry. And we too have written a version of this, as I mentioned earlier, which links observations to explanations, to laws and the ability to solve problems.
It's interesting that the IB exams are going much more towards explanations and calculations. So this idea of being able to explain why something happens is becoming more important. And students often, when they're revising it, they like to revise all these problem type questions, and they forget about the explanations, and that's something they should think about.
Yeah. So as well as making this book, how is it that you as a teacher will feel supported in what you're doing? Within each chapter, we open up with a discussion of the theme as a whole. So for example, space, time and motion. How can you construct a story that links A.1 kinematics all the way through to relativity, that's A.5. We've selected our photographs and our captions quite carefully to hopefully inspire students' imaginations so that you, in a way, don't need to plan so much for the hook that will draw students in. We have those ready-made for you. The IB has guiding questions, similar to the essential idea in the previous guide. We've not only included the guiding questions in full in this book with kind permission of the IB, but we've also at the end of each chapter summarised the answers to those guiding questions. In a way, it's like a revision summary of the topic as a whole. And I think in writing those, we've shown real integrity to what physics looks like. It's not just a list of definitions. It is the definitions that we've covered, but additionally, how it is that those definitions came to be known and how it is they can be applied. Each chapter also has an introduction, the understandings, again, another way for students to prepare for assessment or to know when they're done. They can tick those off as they go. The topic content, of course, the substance of what the students are learning. We have the linking questions, which the IB has introduced this year.
If I just say something about that, the linking questions is something new. I hope you can hear me. My voice is a bit faint due to I'm actually on sick leave at the moment. I have Parkinson's disease, and it makes me speak a bit faint and shake a bit. But I'll do my best to contribute. The linking questions is something that you probably would do anyway as a physics teacher. For example, if you were teaching about velocity, you may just say to the students, is there a fastest velocity, or can we just go faster and faster and faster? And so that introduced the concepts of relativity or mention relativity. You wouldn't, of course, then jump into relativity and start explaining that, but it just gives us some sort of connection to something you're going to do in the future. So those sort of things happen all the way through the syllabus or through the course. And the IB sort of tries to pick some of those out and show how you could possibly do that. In some ways, it also works backwards. When you're doing about, it always works backwards. You're always using things from what you had done in previous lessons all the way through the course. So there's obviously these links.
And likewise with some of the other areas, we've been able to include all of the linking questions that the IB has written, as well as writing many of our own too. The other thing I think that's quite special about this book is that it contains instructions for students to carry out experiments and simulations, both within the book itself and also in the ebook. So I'm not going to claim that it's a 100% completely resourced teaching scheme of work with every single lesson and every single resource written out. But for those of you who are perhaps new to teaching physics or keen to expand your range of investigations, both practical and student modelling, then I think this book will actually provide, in a way, its own form of professional development for you. And then finally, there are many ways for students to practice what they're learning. We've got short, sharp example questions within the text of the chapter. We've also got practice questions at the end of each chapter, and those are drawn from ones we've written ourselves, IB past papers, and we also secured permission to work with a couple of qualitative, quirky question publishers and some from the Institute of Physics and some from the Olympiad as well. So there's a really good range there.
A lot of the questions are the same as the ones in the previous book. We thought there's no point in not using the same ones because teachers often like to know how to do the problems. And if you've used the previous book, then you've already worked out those problems. You might as well use that knowledge again. The answers to questions, by the way, are in the ebook. Often we get asked where the answers are. They're in the ebook, and you can take the PDF of the answers and distribute it if you want, I think.
And I think a typical chapter is something like 100 marks worth of questions, and there's 24 chapters. So in terms of setting your homework for the term, it's sort of all done for you. I maybe am a bit of a traditional old-fashioned teacher, but I don't plan to be printing out very many additional questions on top of what's in the book. So although, yes, I'll have the expense of buying a new suite of books for my students in alignment with the new guide, I don't plan on photocopying very much at all. I also mentioned that the boxes that Pearson textbooks contain. Those of you who've already been using Chris's existing edition will be familiar with these. It's something that I've come to know and really love, and I think this is what makes our book quite distinctive. As well as the worked examples and exercises I've mentioned, we've highlighted the nature of science, the global interrelations between the physics and what's really going on. Some interesting facts, I think, which exemplify Chris's dry but also secretly quite exuberant personality.
Yeah, there is a bit of humour in there still, I think.
Just about.
It
I didn't quite stamp it out.
Sometimes my students are reading the book and they'll say, "I don't believe you've written this. I don't believe you actually dared to write this." But I think Pearson let me get away with some of the jokes in the
Yeah, Pearson and now the IB too.
Yeah.
We've also highlighted theory of knowledge. So if you are a theory of knowledge teacher yourself, or if you have a theory of knowledge coordinator or an IB coordinator on your back to include more theory of knowledge in your classes, again, you don't have to dream that up for yourself. It's ready for you in the book.
The theory of knowledge tends to be very down to earth. I'm no philosopher, so there's not really anything philosophical about it. It's just down to earth physics, interesting bits of physics and how they can be used in theory of knowledge. The worst thing about the physics they often do in theory of knowledge is they pick things that we don't even do in the syllabus, like string theory or something like that, and then try to use those examples. And what the students should be doing is using actual examples from what they do in the class.
Yeah. And finally, I'll mention the challenge yourself questions. We wrote some great challenge questions for this new book.
And we couldn't do them.
We realised that we couldn't just leave them open-ended. We had to actually write the answers. And we've really gone through the guide with a fine-tooth comb to make sure that everything is included. Some of it is included in the form, or I should say, consolidated in the form of these challenge questions. So if you as a teacher want to be confident that you've covered absolutely everything, then by doing everything in the book, your students will have achieved it. So we'll just show you a few screenshots from the book. I've picked the greenhouse effect chapter. It's one that's been introduced for this new guide, kind of links to the energy resources topic of the previous one. So as you can see, it starts with a photograph, and at the top right, there's a caption associated with that photograph. I've actually written something there about modelling of the greenhouse effect and some of the researchers involved in that. We've got the guiding questions, the nature of science and an introduction, the understandings. Now I'll show you, as here, a sort of example of what the notes pages look like. As you can see, there's some good headings to separate out the work. There are figures as well as text. And then also within this same chapter, as you can see at the top left, we've got an exercise. We've then got a modelling exercise with instructions that students can follow.
When I look at this, I always think, how on earth did I ever write all this lot?
Yeah, I've been very, very lucky that Chris has book came before. And then just again to show you what some of the linking questions look like. These are the ones shown in purple. And you can see that a little bonus in this book is that not only have we taken the linking questions from the guide, we have added to them where you can find the actual link. The guide sort of alluded to the link, but didn't actually say where the partnering chapter was. So we've done that for you as well. And then at the end on the bottom right, you can see that we've got those answers to the guiding questions. Here's a typical page, again, the same chapter of practice questions. You can see here we've got a large range of multiple choice questions from past papers, as well as some longer answer questions too.
In the ebook, there's loads more questions as well, multiple choice.
That's correct. Yeah, 10 per chapter on average. So that's another, sort of homework ticked off your list. And I believe, although there's no way for the teacher to see the marks that are achieved in those, you could have students do them within the classroom and then collecting the results at the end. I also just wanted to show you what it looks like in the chapters where there is combined standard and higher level content. You might in the past have purchased separate standard and higher level books for separately standard and higher level students. With this one, of course, you can still do that. But if you're teaching a mixed class, then you might want to have the same book for everyone so that you can refer to the right page numbers and so on. In that case, with the Doppler effect chapter, which I think arguably was the hardest one to write from this mixed perspective, we've got clear statements in bold about what it is that standard level students are required to do and what higher level students are required to do on top. And you can see this little HL rectangle next to the worked example, which shows that that is specifically for higher level students. The reason for this, if you look at the guide for the Doppler effect, is that standard level students require a qualitative understanding, and they need to be able, I think, to use they need to recognize the way in which the frequencies will change, whereas higher level students are required to have a sense of where the equations have come from, and of course the fact that there are different equations for a moving source or a moving observer.
I often go a bit beyond the standard level with my students, with our students now, because when it comes to the internal assessment, if they only do about the Doppler effect as they have to here, they won't really be able to do anything in the internal assessment with it, because they will need the equation. So it's worth them actually going a little bit beyond, I think, in some cases. Same with simple harmonic motion and waves in general.
You know, and I'm very keen that this call, of course, it's related to the book. It's not just a sales pitch. We genuinely quite like talking about physics, but I think I will probably buy higher level books for everyone in the class because of the ease with which I'll be able to communicate with them. And also because there are still plenty of standard level students out there who are exceptionally good at physics, who just happen to be even better at things like history.
The high level ones are more expensive as well, so then we get more percentage.
I was trying not to say that. And again, just to show you how this manifests in the questions at the end of the chapter, you can see that this Doppler effect set of questions mostly is appropriate for standard and higher level students, but there are two parts specifically labeled with that HL rectangle again, which indicate what the higher level students need to be able to do on top. So for you as a teacher, setting the homework for a class of mixed higher and standard level students, you could simply say, please do questions 1 to 5, higher level, you do your bits only. So that's the book. What else have we been working on to help you out? I think we have taken real care, given modern debates on sort of decolonizing the curriculum, to make sure that the examples that we've drawn on are quite interesting and not just constrained to, you know, England, where we happen both to have spent the first stages of our working careers. My accent's from Northern Ireland, but, you know, haven't lived there for a while. So, for example, we've mentioned the James Webb Telescope launch, and we've got a photograph of that, you know, right from December 2021, and its first image of the sky from 2022. On TikTok, students these days, I think, are quite into Rube Goldberg machines, so we've got one of those. We've got a Japanese female breakdancer as an example featured in the section on rotational dynamics. We've mentioned the extreme weather events of last summer, 2022. We've got the Gravitational Waves Observatory, not just CERN, although of course CERN does feature. And I was looking around for where on Earth had the lowest gravitational field strength. Apparently it's in Peru. We've mentioned to a Middle Eastern particle accelerator, which features a lot of international collaboration. That's a really interesting one that students might be interested in as IB learners. That's SESAME. And then we've talked a bit about podcasting and types of solar power station, not just, again, from a UK context, as well as featuring a profile on Lise Meitner. What do you find online? 10 additional labs, 7 additional virtual labs, those that students can conduct on a computer. I've gone through the entire PhET website and I've written a sort of card on how you can connect the relevant simulations with your teaching and what students might achieve from that PhET simulation. So it lists the variables that students might want to play with, how it links and how they might stretch themselves using that simulation. That's something I think is pretty cool and something that I really want to use myself. We have been able to purchase 36 videos for you. I know with YouTube, maybe us buying a few videos for you isn't super relevant, but in this book, we've also got a nice index at the front of what these videos are all about and what they're for and what they show. So again, you can plan your teaching to incorporate these. We've got an annotated IA, annotated according to the new IA criteria. We've also got a section of practice questions for paper 1 section B. That's where the previous paper 3 section A is going to be hiding in the new course. So data analysis questions. I think we've been quite clever there because, again, the IB doesn't specifically have a topic on that. So we're really pleased to have been able to keep the questions that we have and to update them for the new guide. As Chris mentioned, actually it's 12 per chapter, multiple choice questions, automatically marked for the students. And there are answers and worked solutions as well. I think something like 70 pages of answers and worked solutions. That was my Christmas holiday this year. Nearing the end now, how also are we helping you? We've written some sample lesson plans for C3 wave phenomena. We haven't done lesson plans for the full course. Although if that's something that would really excite you, then let Pearson know. Maybe there's a whole other book in that. I'm not sure.
I'm not writing.
I'm not sure I'm the author for it either. But we've got 5 lessons on wave phenomena, water waves, then light, then diffraction and modulation, then double slit interference, and then multiple slit interference. And within each of those, you can get an insight into how Chris and I plan our lessons and think about classes, and crucially, how we would use the book as pretty much our sole classroom resource. And I think this is just to show you an example of what an overall theme page looks like. So this is the very beginning of all of the C chapters on waves. Almost there. We've also got a full chapter on theory of knowledge, which includes very substantial page-length boxes on the theory of knowledge exhibition and essay. I have been a theory of knowledge teacher myself, and I think it's kind of cool that a physicist can get pretty much a worked example on each of these from their physics textbook. Saves you maybe buying theory of knowledge textbooks. Sorry, Pearson. We've got a full chapter on how to write a great extended essay. I believe it's still possible, although Pearson, our amazing hosts, will correct me if I'm wrong, but I think you can still get a free digital trial. We've, as you know, got SL and HL versions of both the book and ebook. We've written some blog posts on the Pearson website, and we also submitted, although I haven't seen them published, some videos in which we go into more detail on things like how we would plan our course of study on these with this new guide. And I think Pearson will share all of the relevant links after the call. All available now.
How do we see everybody?
So now we'll be able to see you. Yeah.
Thanks, Sarah and Chris.
Yes, we're here. Thank you very much, Emma and Chris. And I think this is now time for some questions. So if people want to pop them in the chat, we'll be able to answer them for you. And Catherine Barber, who's online at the moment and is our IB publisher, she'll be leading on the questions on the Q&As. So Catherine, I think there was one question coming in chat earlier from Pankaj, and the question was, has anyone taught IB online, especially sciences, and how was the experience?
Well, certainly during the coronavirus associated lockdowns, I had quite substantial periods of teaching online. I think something I really benefited from with working with Chris was getting ideas for how students could still do practical work around their home. So noticing, for example, that although they might not have the masses and hooks that we have in a physics lab, they had access perhaps to coins, which have known masses.
Yeah. I can't say where I use all my.
We also, a lot of people have access to a thermometer through things like their oven thermostat, for example. So we got through it. I'm not sure I'm queuing up to do it again. I quite like the routine of coming to the lab each day, which we're actually sitting in and seeing the students in the room. But yeah, it's something we felt we got pretty good at, and certainly elements like the multiple choice questions associated with the ebook would be a really awesome tool to have students continually checking in on how they're doing, not just are they keeping up.
Yeah, if anybody on the chat has had experience of teaching online, please do contribute or say something, because I'm sure that's something that you all have some experience from the last few years. There were a couple of other questions that I will ask Emma and Chris, but please do, if you have any questions, put them in the chat, because this is your chance to ask them anything, as this was billed as. So one of the questions is actually kind of for me. It was about the answers and teacher resources and when they will be available. So we are working on adding the extra ebook resources at the moment. So things like the lab skills PDFs, the quizzes that Emma talked about, and the answers and work solutions, and they will be added to the ebooks kind of gradually over the next couple of months, and everything will definitely be live by August. At the absolute latest, it's more likely to be July. So thumbs up for Emma. And Emma also mentioned the free trial, which is still available, so you can still sign up for that. The free trial does not contain all the extra resources because a lot of them are downloadable. We can't really give all that away for free, but you will get access to the full book if you sign up for the free trial. And Emma also did say about the quizzes that she didn't think you could see students' results. So you can actually set the AutoMark quizzes as tasks, in which case you can see reporting and see what students are scoring, but students can also access them themselves kind of on their own Steam. So there's either option, and if the students access them not as an assigned task, then you can't see their scores, but if you assign a task to them, then you can. I think that covers everything on the ebook resources. Somebody asked, you kind of covered this in a couple of different places, but somebody asked, how do you incorporate linking and guiding questions into your unit planning?
So with I guess obviously we would be nowhere without the guiding questions. We would just be guessing what physics to cover. So I would, I suppose, look at those kind of at the start, maybe when trying to weave a narrative through one of the chapters. I don't think they are, if you're a school that's really exam focused, I think you could probably get through it without them, because they're more about how physics has come to be and how one idea leads to another. But I think someone who's interested in physics, a teacher who's interested in physics, will definitely want to look at the guiding questions. And then in terms of the linking questions, I suppose Chris is someone who's got the benefit of many decades of experience, and so kind of knows all of the links that he likes to draw between topics. I'm a little bit more spontaneous than that, although I have now got around 12 years of teaching experience. So maybe I don't think we necessarily map them out for a given class.
I think jumping in as a new teacher, you can't just suddenly be able to do all this. You have to build them up as you go along, and as you years go by, you start picking up all these little links and stuff. I mean, the IB is trying to help you to say these are examples, but really they're up to you to come up with the things that you think need connections.
Yeah.
Thank you. What do you think would be the possible improvement in students' results score for the 2025 group after the syllabus review?
Ooh.
No idea.
No idea. I imagine that the results this year are going to be a bit of a mystery to all of us, because the IB has said that on the whole, they're going to try to bring results back to the distributions that they would typically have had pre-2019. So we'll see if that distribution re-emerges. I have to say, I don't think physicists were overly affected by the pandemic on a global scale, because grade boundaries last year, which were supposed to be generous, actually struck me as pretty much at the harshest end of what I've ever seen before. So we will see what happens in 2025, but I imagine that about 6% of people will get a 7 around the world, which is typically what the IB aim for in most courses.
Thank you. We don't have any more questions at the moment, so we'll just give it a couple more minutes. There will, I believe, Alara can confirm, be an email with a link to the recording and where you can access the free trials, etc. Alara, that's true, right?
Yes, that's absolutely true. So we will send an email around with a link to the recording, which is usually available on our website in between a day or two after the end of the webinar. And also there will be a link to a quick survey. And if you could fill that in for us, that would be great. Just to let us know whether you enjoyed today's webinar and the great job that our authors have done today. I think there is another
Yes.
question in chat.
Yes, so Daniel has asked, this is specifically about ManageBack, but I think it probably applies in general. So Daniel asked, how do you do unit planning on ManageBack? Do you create 5 massive plans for each theme, or 25 smaller plans by topic?
I personally will be doing the 24 ones broken up into the subunits, because I won't be because that'll give me the ability to sort of manipulate the order according to how I actually want to teach. I would envisage not doing, for example, rotational dynamics immediately after, kinematics and energy and so on. I'll probably move to some other standard level topics and then come back to the higher level ones at the end. And that'll give me the most amount of flexibility in order to do that.
Well, I've retired, so I won't be doing anything.
Retiring on a good moment.
Yeah, retiring on a high.
Yeah.
Okay, thank you. Daniel says thanks as well. We don't have, oh, sorry, Emma, no.
Yeah, I think just one other thing I'll say is that, for us, the thing that might most guide the order in which you teach is not necessarily, of course, you can think about the story that you want to map out through the whole course, but for us, it would be step 1, decide when you want to do the coursework, sometime between, the later stages of maybe the second term or the beginning stages of the second year. And then that is the point at which students need to have amassed a good body of knowledge in which to ask research questions and know how to manipulate the apparatus. That's the question we're most often asked. And I think for me, that's the single most significant influence on the order in which I would teach.
Thank you. We don't have any more questions. So thank you everybody for joining and for your insightful questions. Thank you again to Emma and Chris for sharing your knowledge and experience with us. Harsh has just put the email address in the chat if you have any further questions. Any final words from Emma and Chris?
If there's anyone out there that we know, then hi, because we can't see who's there. So probably some of the people we know from workshops and stuff. But,
Oh, and I can also share, after 6 years of waiting, I've been accepted for workshop leader training.
Yay.
Amazing.
Be able to see some of you in person in a glamorous European city next year.
That sounds
Excellent.
lovely. Okay then, well, thank you very much again, Emma and Chris, and thank you to all of you for joining us today. I just remind you, Harsh has put an email address in chat. If you need to reach out to us, please email us at internationalschools@pearson.com. And I think this concludes our webinar for today. So thank you again, and have a good rest of the day. Bye.
Thanks. Bye.
Bye.